Hello friends, now we will be discussing numerical problems based on highway geometry design horizontal curves. Okay, so we will be discussing numerical problems, numerical problems based on highway geometry designs, the horizontal curves, horizontal curves. Okay, so moving on to question number 1, that is a horizontal curve of radius 600 meters on two-lane highway. Let us side by side write down the data also. So here it is given that the radius is 600 meters. So the radius is 600 meters on a two-lane highway with width is given to be 7 meters, is to be designed to cater for mixed traffic at speed of 65 kilometers per hour. So the design speed given is 65 kilometers per hour, which we need to convert into meters per second. So the small v equal to 65 into 5 by 18, that comes out to be 18.05 meters per second. Okay, so yes, the raise of outer edge of pavement with respect to ground level if the pavement is rotated with respect to center line and if the pavement is rotated with respect to inner edge. So here it is given that we have to consider the mixed traffic condition. So our standard formula is E plus F equal to V square upon GR, and as per the given conditions we want to find out the value of E. Okay, we want to find out the value of E plus, in step 1 F is considered to be 0 because it is the step where we consider the equilibrium super elevation, and for mixed traffic condition it is 0.75 into 18.05 square upon G is 9.81 into radius is 600 meters. Okay, this is step 1 always. In step 1 what we consider is that equilibrium super elevation, and second point is considered is the mixed traffic. Okay, we consider the mixed traffic. So here the E value comes out to be 0.031, E equal to 0.031. So guys, suppose this is our this is E and this is B equal to 7 meters and E is 0.031. So capital E equal to B dot E equal to 7 into 0.031 equal to 0.22 meters. Here it is important to note that we have stopped at step 1 itself because the question neither speaks about the maximum super elevation nor it speaks about the type of terrain. Okay, so therefore there is no need to compare it with Emax, and it is less than Emax. Usually Emax is 7%, but it is not given, so we need not compare it with Emax. But the question here mainly is asked to understand that if the pavement is rotated about the inner edge, then 0.22 meters is the raise in the outer edge. So here I have answered the B part of the question, that if the pavement is rotated with respect to inner edge, then 0.22 is the raise of outer edge. Okay, and if the pavement was rotated about the inner edge, then E equal to 0.22, rotated about the center line, then E equal to 0.22 by 2 equal to 0.11. Okay, so here the case is in A, the case is like this, it is this way, this way. So it is E by 2 and again E by 2. Okay, so the raise is measured from the ground level, and in both the cases ground level is here. So in this case ground level is here, so E is E by 2, and in this case E is capital E. So this question was asked to check your understanding, that you should know that whether you know the if it is rotated about the what is the capital E value when it is rotated about the inner edge and rotated about the center. And you may consider to note down that here, since you may consider writing the reason for stopping at step 1 itself, and when you stop at step 1 itself, that means you assume that E calculated is less than the E max that is permitted when we are trying to provide the equilibrium super elevation. Okay, but here we don't have E max value, so we have not considered and we have assumed that the E calculated is less than E max, since the maximum super elevation value is not given, and also the terrain value is not given, the terrain type is not given. So now let's move ahead to question number 2, that is, a highway is designed for a speed of 66 kilometers per hour, 66 kilometers per hour, which is equal to V equal to 66 into 5 by 18 equal to 18.05 meters per second. Sorry, it is not 66, it is 65 kilometers per hour. Okay, 65 kilometers per hour. And to carry mixed traffic, the super elevation is not to exceed 7%. So it is given here that E max equal to 7%. And the coefficient of lateral friction is given to be 0.15. The radius of horizontal curve is given to be R equal to 125 meters. Then which of the following statements is correct? So the options are: design speed of 65 kmph is allowed, maximum speed can be allowed up to 30 kmph only, maximum speed allowed can be 59, and again see, each of the option is speaking about the limiting the each of the options speaks about limiting the design speed. Okay, limiting the speed. So where we studied this limiting speed, so the step number 3 speaks about the limiting speed, limiting the speed on the super elevation on the horizontal curve. Okay, so let us check out what step number 3 says in the design of horizontal curve. So I'll write down steps distinctly. So the step 1 is that our general equation is E plus F equal to V square upon GR. Step 1 has got two conditions. Condition number 1 is equilibrium super elevation, and secondly what it considers is that mixed traffic. So E plus F equal to 0 for equilibrium super elevation, mixed traffic 0.75 into V square, small v square is 18.05 square upon 9.81 into 125, which gives value of small e as 0.149, and which comes out to be greater than 7%, that is 0.07. Here 7% stands for 0.07. Okay, so which is not safe. So move on to step number 2. Move on to step number 2. Not safe, and move on to step number 2. So step 2 is, here we consider the maximum super elevation, and we check for whether the friction is sufficient or not. So we will be checking for the friction. So Emax plus F equal to the full design speed is considered. So V square upon GR. Okay. So Emax is 0.07 plus F equal to 18.05 square upon 9.81 into R is 125, which stands for F equal to 0.1956, which is greater than 0.15, which is again not safe. Okay, so not safe, instead of saying not safe, I'll say it is not sufficient. Okay, so this is 0.15 is the friction coefficient available, but the required is 0.19, so the friction coefficient is not sufficient. So in step 2, you should keep in mind that there are two considerations, that you consider Emax and you consider the full design speed, and check for that whether the available friction is sufficient or not. Okay, full design speed is considered since we want to check for the critical case. Okay, Emax and full design speed are the critical cases. So this step number 3, we will now go to step 3. Step 3 limits the velocity, limits the permissible speed. So the formula will be Emax plus whatever is the value of F, and equal to, again this will be with respect to the full design speed, it is V square upon GR. So Emax is 0.07 plus 0.15 equal to V square upon 9.81 into 125, which stands for V equal to 16.42 meters per second, which is equal to 59.112 kilometer per hour. Okay, so I guess it is, so this is the limiting velocity. Okay, so whenever we are providing super elevation equal to 0.07, that is 7%, whenever F to be provided is 0.15, and at that time the velocity can be only up to 59.112 km per hour, even though the design speed is 66 kilometers per hour. Okay, but we have to now limit our velocity to 59.112 km per hour. So option number C is the appropriate choice, that maximum speed can be allowed is up to 59 kilometers per hour. So guys, you should be very much clear about the design of super elevation. Okay, so for recap, I'll repeat it, that there are 3 steps. Step number 1, we have got one basic formula, that E plus F equal to V square upon GR. In step number 1, there are 2 considerations, that first one is we consider the mixed traffic condition, and second one is we consider the equilibrium super elevation. Okay, mixed traffic condition because we have to design it for the vehicles of varying speeds, and equilibrium superposition because it is the most desired alignment, that is the most desired thing in the highway designs. Okay, so our formula modifies to, and equilibrium super elevation stands for F equal to 0, and so that E plus 0 equal to 0.75 times V square upon GR. Okay, this is where the formula gets modified, and from here E calculated, whatever the value we get, if it is less than the E max allowed. Okay, E max allowed. Now this depends, at times it is given, or E max is 7% for plain and rolling terrains. Okay, for plain and rolling terrains, and it is 10% for hilly terrains, hilly and mountainous terrains, and it is again 7% for hilly terrains, hills plus snow. Okay, it comes from IRC, that is the limits of super elevation. Fine. So if it is less than Emax allowed, then go for the calculated E value. Okay, if it is the calculated E value is greater than Emax, then go to step 2. Okay, go to step 2. Okay, so what step 2 does is checks the available friction for Emax and maximum, that is the design speed. Okay, you have to set this value to, you have to adjust this E calculated value to Emax and go to step number 2. So the step number 2 will be Emax plus F equal to V square upon GR, if, and check that this F calculated value is less than 0.15, and whether it is less than 0.15, then it is okay, it is safe. Okay, then we can provide Emax itself, sorry, E calculated as small e itself. Okay, the Emax itself. Okay, and if F calculated value is greater than 0.15, then it is not safe. Okay, not safe, or better I say that the friction is not sufficient for resisting the Emax. So adjust friction to, in this case, adjust friction to F equal to 0.15 and go to step 3. Okay, so the step 3 will be using, use E equal to Emax and F equal to 0.15 or whatever the value is given. Reduce the speed on the curve, that is, I'll say limit V. Okay, so here the formula will be Emax plus 0.15 equal to V square upon GR. So G is known, R is known, Emax is known, and this value is also known. So V limit equal to what? You have to limit the velocity. This is the final step in the design of super elevation. And once you limit the velocity, you should put a mandatory signboard like this, stating that the maximum speed allowed is 70 kilometers per hour or something like this. Okay, should put up a board on the road. Okay, so I hope that the design of super elevation is now very much clear to you. Okay, I have repeated it twice now. So we will move on to the next question, question number 3, that is, determine the following for a road on a horizontal curve in planes of radius 500 meter. Okay, so given that R equal to 500 meters, design speed is given to be 100 kilometers per hour, coefficient of lateral friction is given to be 0.15. Convert this to 100 into 5 by 18, that is equal to 27.77 meters per second. 27.77 meters per second. Okay. So now we have to find out the super elevation required for the road when full lateral friction comes into play. Okay. So the super elevation is to be calculated when full lateral friction is available. Okay. So our general formula is, so solving A, that is E plus F equal to V square upon GR. Okay. So as per the question, E plus F is 0.15 equal to 27.78 square, 77 of 78 square upon 9.81 into radius is 500. Okay. That gives E equal to 0.73. Okay. So into 10 to the power minus 2, that is equal to 0.73% we can say. Okay. So moving on to question number B, that is question B is they are asking coefficient of friction when no super elevation is provided. Then using our basic formula, this formula is the basic formula, and so that no super elevation, that is E equal to 0, and F is what, and V is 7.78, 27.78 square, 9.81 into 500, the same thing, and then F calculated is 0.157. Okay, just a very simple question, guys. Equilibrium super elevation required for pressure on inner wheel is equal to that of the pressure on outer wheel. So in order to go about this question, question number 3C, what you should know that for equilibrium super elevation, F equal to 0. So just put the values in E plus 0 equal to speed is 27.77 square upon 9.81 into R is 500. That gives E equal to 0.1573, that is equal to 15.73%. Okay. So I guess the things are clear to you now, and we should keep on moving ahead. Okay, guys. So the next question is super elevation for mixed traffic condition if the design speed is 60 kilometers per hour with other parameters remaining the same as in the main problem. So it is just that V is given to be 60 kilometers per hour, which is equal to 16.67 meters per second, and they are asking what is E. So E plus F will be 0 equal to 0.75 V square upon GR equal to E equal to 0.75 into 16.67 square upon 9.81 into 500 equal to 3.2%. That is, here we are providing equilibrium superelevation. Okay, since F value is 0. So the next question is, what will be the ruling radius of horizontal curve on a national highway of a design vehicle speed of 100 km per hour? Let us write down V equal to 100 kilometers per hour, which is equal to 27.77 meters per second. Guys, by now you should know it, like you should know that 100 km per hour stands for 27.77 meters per second. Okay, and allowable maximum super elevation is 7%, and the lateral friction is 0.13. Okay, lateral friction is 0.13. Okay, so in this case we are supposed to find out what is the ruling radius of horizontal curve. So here we should use the ruling design speed. So we have got E plus F equal to V square upon GR. E put 0.07, F we can put 0.13, E we have to, sorry, R we have to find out. P is 27.77 square, G is 9.81 into R gives R equal to 393.05 meters. Very simple question is, okay, but it is asked, it is very frequently asked, the question on the ruling radius of horizontal curve. It is many times asked questions. Okay guys, I've seen this question many times in entrance exams, in the competitive exams. So the next question is, the centrifugal ratio of the vehicle is 0.25. So it is given that P by W equal to 0.25. Width of the vehicle is 2.4 meters. Height of the vehicle with CG equal to 4.2 meters. Lateral friction is given to be 0.15. Assuming no super elevation, the lateral skidding takes place. Okay, overtaking. Okay, these are the options. Okay, assuming no super elevation, assume that there is no super elevation. Then which of the following occurs? Whether it skids or it overturns first, it neither skids nor overturns, or both of them happen simultaneously. So since the super elevation is given to be 0, so we don't need this formula. So in this case, P by 2H, P by 2H is equal to 2.4 by 2 into 4.2 equal to 0.28, and the F value is equal to 0.15. So B by 2H is greater than, B by 2H is greater than P by W, and F is less than P by W. Okay, so these two, B by 2H and F, these are the resisting forces. So it can be seen that the resisting force against skid is less than that of the P by W, hence it skids. Okay, but the overturning force is, overturning resisting force is greater than, it is not force actually, it is the coefficient or the fraction, you can say something, the factor you can say, the overturning factor or the coefficient is greater than overturning resisting factor is greater than the speed, the force that is coming, so doesn't overturn. Okay, so the option is option number P, that is option number A, that is lateral skidding occurs first. Lateral skidding occurs first. So we are done with this question, and we are also done with the numerical problems on horizontal curves. So guys, just a recap, there are in this chapter of horizontal curves, okay, it is part of highway geometry design, and in this chapter what we studied was we initiated with some theoretical concepts on the horizontal curves. Later on we discussed the overturning and the skidding, and later on we discussed the design super elevation. So the numerical problems are of mainly two types. The first type is based on overturning and skidding. They will ask whether the vehicle skids or the overturns or etc etc. And the second type is on design super elevation. Okay, so there are only two types of numerical problems, and please prepare well. It is very much suitable type for GATE examiners, to ask these two type of numericals in the GATE examination or any competitive examination. So please prepare well, and we stop here. Thank you so much. Now we will move on to the next concept of the highway geometry design, that is extra widening on horizontal curves. So the name itself suggests what extra widening on horizontal curves is. That is, if there is a straight road, and for straight road, if the width is provided is, say, for two lane road, the width provided is 7 meters, but the same road, when it encounters a horizontal curve, there is some additional width provided in addition to the 7 meter. Okay, so there is an extra width that is known as the extra widening on horizontal curves, and there is good reason why to provide this horizontal this extra widening on the horizontal curve. So the reasons I'll discuss, but the extra widening provided is composed of two terms, that is the extra widening because of the mechanical widening it is called. Okay, so better we call it as mechanical widening, and the second one is that the psychological widening. So the extra width provided is Wm plus Wp, where Wm is mechanical widening. I'll discuss what is mechanical widening. Okay, and Wp is psychological widening. Okay. So we will be now discussing what is mechanical widening. I hope you understood that it is nothing but some additional widening, the additional width of the road is provided on the horizontal curves for some reason, that is some mechanical reason and some psychological reason. We will discuss what the reason exactly are. Okay, so as far as mechanical widening is concerned, over the curved road, the rear axle comes out of the track and follows a closer path. Okay, so what happens is that if a vehicle is moving on straight road, so I'll say that on straight road, the scenario will be of this kind, that vehicle, suppose this is the vehicle, is the front axle and the rear axle. Okay, so like this. Okay, so there will be straight, this will be the track followed by the first wheel, and the same track will be followed by the second wheel. Okay, on straight road. But in case of curved roads, what happens is that in case of curved roads, suppose this is the vehicle, okay, front axle and the rear axle. Okay, these are the wheels. Okay, what happens is that the front axle is turned like this. Okay, front axle is turned like this. Okay, and the front wheel follows this trajectory, and this follows this trajectory. But what rear wheel does is that instead of following this trajectory, it takes a shorter path like this. Okay, and this is what is Wm. That we call as mechanical widening, which is also known as off tracking. So this is basically off tracking, which is provided as mechanical widening. Okay, and off tracking is an exclusive word for vehicle. Okay, an exclusive word for vehicle. because for every vehicle the off tracking is different based on the length of rigid wheelbase. The length of rigid wheelbase, this one, length of rigid wheelbase, and the radius of the curve that is being encountered. Okay, so it depends on length of the rigid wheelbase and the radius, that is the turn, how much turn the vehicle is taking. Okay, so over the curved road, the rear axle comes out of the track and follows a closer path. The distance between the two tracks is called off tracking. Okay, is called off tracking. So I have shown over here what is off tracking. Okay, and this off tracking is provided as mechanical widening. Okay, so we will study how to calculate what is the off tracking for given vehicle. Okay, yes. So the scenario will be of this kind. This is our vehicle. This is our vehicle having length L. Okay, this is length L. Okay, so what happens is that from here the one wheel, the front wheel, takes this path. Okay, say it takes this path. It takes this path. Okay, and the rear wheel takes this path. Rear wheel takes this path. So this is WM. This is WM. Okay, this distance is WM, and this is equal to, this is R, and this is also the R. Okay, fine. So from the triangle OAB, from triangle OAB, okay, R plus WM square, R plus WM square equal to R square plus L square. This R square plus this L square. Okay, so what we get is that R square plus twice of R WM plus WM square equal to R square plus L square. So this R square and this R square gets cancelled. WM is very small and WM square will be again very small. Okay, so this WM is very small compared to R, so we cancel it to 0, and what we get is, we get from these two terms are left, that is twice of RWM equal to L square. Therefore WM equal to L square upon twice of R. Okay, so WM equal to L square upon 2R. So this formula represents the off tracking of one vehicle on road. Okay, so this formula represents off tracking of one vehicle on road, and therefore mechanical widening, okay, mechanical widening of the road with n number of lanes, with n number of lanes, with mm, with n number of lanes, with n number of lanes, n number of lanes will be given by Wm equal to NL square upon 2R. Okay, so this was for only one lane. Okay, but the road has got n number of lanes, so we say that there will be n number of vehicles stand adjacent to each other. That's why the psychological widening for those many lanes will be given by NL square by 2R. Okay, so I hope that you understood from where we have drawn this diagram. This is the front right wheel. Okay, and this one is the trajectory taken, the track followed by the rear right wheel. Okay, just exactly this one. We are drawing the trajectory for these wheels. Okay, the trajectory taken by the front right wheel and the trajectory taken by the rear right wheel. We are considering these two tracks and correlating them with the uh, radius of the curve, and using some trigonometry, the triangle laws, we are finding out and making some assumptions. We are finding out what is the mechanical widening that is required for that vehicle. Okay, so there is a very famous question based on this. And the question is I'll use this space for that question. Okay, so the question is, a vehicle is moving on six lane road. What is the off tracking of vehicle? So please think on this. I hope that I should write down formula for the mechanical widening. So Wm equal to NL square upon 2R. So guys, please try out yourself. Okay, extrapolate from what I have taught. Let's try it out. The n value is 6, since it is 6 lane road, n equal to 6. And what is the off tracking of the vehicle? Okay, so the option A is L square upon 2R. Option B is 6L square upon 2R. Okay, or maybe you can say 3L square upon R. Okay, option C is 7L square upon 2R, and option D is none of the above. Okay, so please tell me what will be the off tracking of the vehicle when the lane is 6 lane road. What is off tracking of the vehicle when the lane is 6 lane road? Okay, so let's move ahead. That guys, I have explained you just now that off tracking is a term that is exclusive for vehicle. I have mentioned here that off tracking is a term that is exclusive for vehicle. Okay, it is exclusive for vehicle, and we are extrapolating it to use for one lane. Okay, so the question is, they are not asking that what should be the extra widening to be provided on the road, but the question asked is what is the off tracking of the vehicle, which is irrespective of number of lanes. So option A is the correct answer, that is L square upon 2R. Okay guys, so now let us move ahead. Okay, so the next type of widening is psychological widening. So we discussed that extra widening consists of mechanical widening and the psychological widening. So now let us study what is psychological widening. So the vehicle is taken outwards over the curb to avoid hitting of vehicle to the rotary. Okay, suppose there is a curve like this. I should draw better diagrams from next time. Okay, suppose there is curve like this, and there is, say that there is a rotary like this, and the road is following this rotary. Okay, then here what the drivers do is that suppose they are driving this way, okay, then they intentionally, instead of taking this trajectory like this, instead of taking this track, they follow this path. Slightly outside they'll go. Slightly they'll go outside to be safe enough to ensure that the vehicle is not hitting this rotary. Okay. So it is psychology of human beings. Okay. It is psychology of human beings. So as per psychology of drivers, the vehicle, they take vehicle outwards over the curves to avoid hitting of the vehicle to the rotary. To facilitate this problem, extra weight is provided, which is known as the psychological widening. And to facilitate this, okay, we provide an extra width, that is WPS, which is the psychological widening. Okay. Okay. So the psychological widening is given as WPS is given as V upon 9.5 under root of R. Okay. V upon 9.5 under root of R, and remember that this formula is empirical one. This is an empirical formula where V is design speed in kmph and R is radius of the curve in meters. Okay guys, and from this you get WPS in meters. You get WPS in meters. Okay, and so that the total widening, is given as WE equal to WM plus WPS, which is given by NL square upon 2R plus V upon 9.5 R root R. Okay, WE plus W equal to NL square upon 2R plus V upon 9.5 R. Okay, so let us now take some numerical example based on this. Okay, so the numerical example: a national highway with design speed of 76 kilometers per hour, national highway with design speed of 76 kilometers per hour, okay, which is equal to 21.11 meters per second, and width of the pavement is 7 meters. The length of wheelbase is 7 meters, and super elevation provided is 1 by 15, and coefficient of friction is 0.15. So that ruling minimum radius of the curve in meters is okay. So I hope you understood how we got this. Okay, so we have got formula for ruling minimum radius on the curve. Okay, we have got formula E plus F equal to V square upon GR. Therefore E is 1 by 15, F is 0.15, V is 21.11 square upon G is 9.81 into the radius is what? The ruling minimum radius of the curve. Okay, so if you calculate R equal to 209 meters, this is the ruling minimum radius. And the question B is total width of pavement on horizontal curve is in meters. So on a horizontal curve we need to provide extra widening. Okay, so extra widening, that is WE is given as WM plus WP, which is equal to NL square upon 2R plus capital V upon 9.5 root R. Okay, this is WM and this is WP. Okay, so number of lengths Number of lanes. What is number of lanes? Tell me. Then the width of the pavement is 7 meters. What is the number of lanes? Please tell guys. So when pavement width is 7 meters, then the number of lanes is 2 and the length of rigid wheel base is 7 upon 2 into radius that we have just calculated, that is equal to 209 plus capital V is 75 upon 9.5 into root of 209, which gives you answer equal to 0.78 meters. 0.78 meters. So the question asked is total width of pavement on horizontal curve in meters is. So what this is, 0.78 is the extra widening. Okay, it is simply extra widening. But the total width on road, total width of pavement. So the total width equal to 7 plus 0.78 equal to 7.78 meters. I hope it is clear to you. It is very straightforward question, and yes, at times such kind of questions are asked in GATE or in whichever the examination. Okay guys, so let us now move on to question number 2. And this question number 2, that question was asked in GATE 2008 examination. Okay, so it is previous GATE question guys. Now you will understand how the GATE questions are. So the extra widening required for 2-lane, so N is 2-lane national highway at a horizontal curve of radius R equal to 300 meters, considering the wheel base of 8 meters and design speed of 100 kilometers per hour is. So what is the extra widening required? WE equal to what? Okay, so what is the extra widening? So we know that extra widening is given as Wm plus Wps, which is equal to NL square upon 2R, plus Wps is V upon 9.5 under root of R, which is equal to 2 into h square upon 2 into R is 300 plus P is 100 kilometers per hour upon 9.5 into root R is 300. Please calculate yourself and tell me the answer. Okay? Calculate and tell me what the answer is. So the answer is 0.82 meters. Okay, so right here that 0.82 meters. 0.82 meters. So this is the extra widening required for 2-lane national highway. 0.82 meters is the extra widening. So you might have realized that even in GATE 2008 the questions are so straightforward and so simple, and you just need to remember this formula, these two formulae. If you really practice well guys, it is very easy to remember this formula. That for engineers it is very easy, that it is obvious that mechanical widening will be based on the number of lanes, it will be based on the length of rigid wheel base, and it will be based on the radius. Either you can remember the derivation for this, or you can simply remember that NL square upon 2R. It's very easy to remember this. And the psychological widening, slightly difficult formula to remember, that V upon 9.5 root of R, but I'll always suggest that you may use some trick on your own. I've got my own trick to remember this formula, and you should find your own trick to remember this formula. And I know how guys are very expert at remembering such tricks. Okay, so now let us move on to next question, that is question number 3 or question number 4, but whatever. This is GATE 2010 question. GATE 2010 question, the previous last question. So the question is, the design speed for 2-lane road N equal to 2. The design speed is 80 kilometers per hour when designed vehicle with wheelbase of 6.6 meters is negotiating a horizontal curve on that road. The off-tracking measured is 0.096 meters. I hope what you understood what is off-tracking. So the vehicle is like this, and this wheel takes this trajectory. This wheel takes trajectory like this. It takes trajectory like this, but this wheel takes path like this. So this is the off-tracking, okay, which is given as Wm, the mechanical widening. So indirectly they are saying the mechanical widening is 0.096 meters. The required widening of the carriageway of the two-lane road on the curve is approximately what? The required widening of carriageway of the two-lane road on the curve is approximately what? Please try out this question on yourself. So it is GATE 2010 question. GATE question has to be slightly tricky. So let us try to solve this question. So the extra widening is given as mechanical widening plus psychological widening. Mechanical widening is NL square upon 2R plus psychological widening is given as V upon 9.5 root R. So the question is required widening of the carriageway of the two-lane road on the curve is approximately. So N is two-lane road, right? So 2 length of rigid wheelbase is 6.6 square upon again 2 into what is the R value? R is missing. So R is not known to us. So I'll leave this space blank, okay? The space for R I'll leave blank. So the V value we have 80 kilometers per hour. It is an empirical formula where we put V value in kilometers per hour, and 9.5 into radius, again R is missing. So we need to use the earlier given information, the information given in the earlier statement, that off-tracking is measured as 0.096 meters. This is the additional information that we have. We use V, we use N, we use L, we want to use R in this formula, but this is an additional information. So we should use this information, get some equation and find the R value. So off-tracking of a vehicle, that we know that mechanical widening is given as NL square upon 2R, and off-tracking is given as L square upon 2R. Fine guys. So the off-tracking is given as L square upon 2R. I hope you all agree to this, and there is no N in this formula here, N equal to 1, okay, because off-tracking is for a single vehicle. So the off-tracking equal to 0.096 equal to 6.6 square upon 2 into R. Okay, now one equation, one unknown, so we get R equal to 226.87 meters. 226.87 meters. Okay. Use this R value over here. Put R equal to 226.87, and here also 226.87. So the widening required, the value comes out to be 0.7510 meters. 0.7510 meters, and which is option C. So this is what the GATE 2000 question was. And see guys, very simple. If you know the formula, you can easily do it. Instead of directly asking this question, they just included some slight trick, and where most of the students get confused. In fact, when they say that the off-tracking is so and so, they blindly use the N equal to 2 in this formula and make mistake. So even they know even they have put efforts in keeping the formula in mind, but they make such kind of mistakes, and which leads to their bad score in GATE examination. So you have to be very attentive, and instead of solving question in single go, they put some trick and make at least 2 steps So that question becomes a gate question, the question that is worth for gate examination. Okay, so I hope you all have understood how to go about this, and here we end this chapter, that is the extra widening on the horizontal curves.